So I started this unit with an example of an aeroplane. So let us understand what actually happens, what are the forces acting on the aeroplane. Okay, so we have this aeroplane flying. Okay, so this is our aeroplane. Okay, this is the last aeroplane of Kingfisher airline, I guess. After this, Vijay Mallya flew to the London. Okay, so let us understand what are the forces acting on this aeroplane. So the very first force which acts on the aeroplane is the weight of the aeroplane, which obviously will act downward. Second force which will act is the thrust force, which is because of propeller, which helps the aeroplane to move forward, the thrust force. Now opposite to the thrust force, there is a force acting which is called as the drag force. And opposite to the weight of this aeroplane, a force acts which is called as the lift force, which is actually responsible for lift of this aeroplane. So we know enough about weight and the thrust force. Now in this particular video, we are going to study about drag and lift force, which affects the flow of an aeroplane. Okay, so what actually happens when the air is, or when this aeroplane is flowing across the air? Okay, the air is coming across this aeroplane, across the wings of the aeroplane. So what are the forces which actually develops along the wings or along the aeroplane, body of the aeroplane? Okay, so let us consider a body. Forget about aeroplane, just consider a body here. And when the fluid is flowing around this body, the resultant force which is developed is suppose Fr. Okay, now how this Fr develops, I will tell you. Resultant force is Fr. Now this Fr will have two components. First is the horizontal component, which is called as the drag force, which acts in the direction of flow of fluid, or you can say in opposite to the direction of flow of the body. And second component is the lift component Fl, where the vertical component, which is called as the lift component Fl. So how are this drag and lift force, or this resultant force which we are talking of, acts? So whenever a body comes in contact with the fluid, there are basically two types of interaction, two types of forces acting. First is the force due to shear stress, which acts along the body, and second is the force due to the pressure, which acts perpendicular to the surface of the body. So these are, you can see here, the two forces. First is acting along the body and second is acting perpendicular to the body. Now just consider that a small strip in which the pressure force PdA is acting. Because of pressure, the pressure force will act, which is nothing but P into dA, pressure into area, which is acting at an angle theta from the vertical, and the shear stress, the force due to shear stress tau, is acting on the surface of the plane. Okay, now let us resolve these two forces. So the PdA can be resolved as PdA cos theta, the vertical component, and PdA sin theta, the horizontal component. Similarly, tau dA can be resolved as tau dA cos theta, the horizontal component, and tau dA sin theta, the vertical component. Okay, so the horizontal component will contribute to the drag force, and obviously the vertical component will contribute to the lift force. Now the total drag force Fd, you can resolve the component, you can get the value. So this Fd will be equal to P dA into sin theta plus Fda into cos theta, and because that is taken for this small area, if we want it for the complete body, we will have to integrate it. So it will be integration of P sin theta plus F cos theta into dA. So this has two different components. First is the P sin theta into dA, which is called as the pressure component, and second is F cos theta into dA, which is called as the friction component. Now what if we are having a vertical body? Suppose we are having a vertical plate. Now in this case, theta is equal to 90 degree. The pressure force is acting in horizontal direction and the plate is vertical, so theta here will be equal to 90 degree, and because theta is 90 degree, so the cos component, cos theta, will be equal to, the term of cos theta will be equal to 0, and the drag force which we are having is just the pressure drag and not the friction drag. That means Fd will be equal to integration of P into dA. Okay, theta is 90 degree, cos theta will be equal to 1. So Fd will be equal to integration of P dA. Since theta is equal to 90 degree, so sine of 90 will be equal to 1. Okay, now what if we are having a horizontal plate that is placed along the stream of the flow, stream of air? If we are having a horizontal plane, then what will happen? Then theta is equal to 0 degree. Okay, and since theta is equal to 0 degree, sin theta will be equal to 0, sin 0 will be equal to 0, and we will be having only the friction component and not the pressure component. Okay, that means total drag force Fd is equal to the friction drag, which is equal to integration of tau into dA. That's it. Okay, so if we are having a vertical body, only pressure drag will act, and if we are having a horizontal body, Vertical body in the sense the body placed in the direction perpendicular to the direction of flow of the air, that we are calling as vertical body. We are assuming the horizontal flow. And if we are having the body which is placed along the flow of air, then we will be having only the friction drag and not the pressure drag. Okay, so now coming to the lift force FL, which is equal to integration of P cos theta minus tau sin theta into dA. Now in this, tau sin theta is having very small value. Okay, so as you can see, the shear stress is acting along the plane. Okay, so the vertical component will be almost equal to 0 and can be neglected. Okay, so we will be having FL is equal to integration of P dA into cos theta. This is the lift force. Now how we can represent this mathematically, the drag force and lift force? What will be the values of this drag force and lift force? So the drag force FD will be equal to CD into half rho A U square, and the lift force FL is equal to CL into half rho A U square, where CD is the drag coefficient, CL is the lift coefficient, rho is the density, U is the velocity of flow, and A is the projected area. Okay, the maximum projected area of the body. Now coming to the airfoils, as you can see the airfoil, I will tell you basic terminologies of this airfoil. First is the chord line. The line joining the leading and trailing edge of the airfoil is called as the chord line. Second is the profile line or camber line. You can see here the line joining the midpoints of the profile is nothing but the profile line or camber line. Third is the angle of attack. So the angle between the chord line and the undisturbed velocity is nothing but the angle of attack, which is represented by alpha. Now initially, as the angle of attack increases, the lift will increase, but after a certain point, as the angle of attack increases, now the boundary layer separation starts shifting towards the front edge of the airfoil. Okay, and lift starts diminishing. So the point after which this lift starts diminishing is called as the stall point, and the angle at which we are getting the maximum lift is called as the stalling angle. Now as you can see, beyond stalling point, since the boundary layer separation is shifting towards forward direction, okay, so at back there will be wake formation, and because of this wake formation there will be more and more drag force. Now what is the reason for lift force here? Now when the airplane fly, the above airfoil there will be a negative pressure field, as you can see here, and below airfoil there will be a positive pressure field, and because of this pressure field, because of the difference in pressure, this the airplane will experience a lift force and it will fly. Okay, so these are all about airfoil. We are not getting into much detail here because not much questions were asked from this. Okay, so we will just solve one or two questions from here. Thank you so much.